Today we're going to talk about similar polygons. And to start, we're going to talk about a few vocabulary terms. First thing we're going to talk about, which applies to similar polygons, would be a proportion. Proportion is simply two fractions that are equal. All right, for instance, 2/4 is equal to 1/2. Okay, those are the same. Same thing with, for instance, 6/9 is equal to 2/3. Those are the same. Sometimes we get proportions that have a missing number. All right, so in order to solve a proportion with a missing number, we cross multiply. So that's used to solve a proportion. So if we're going to go 6/9 is equal to x over 3, all right, we would cross multiply. We go 9 times x, which is 9x, and then 6 times 3, which is 18, and then we'd solve for x. So in that case, x is 2. Okay, next we're going to talk about what makes shapes similar. Okay, first of all, they have to be the same shape, but usually they're different sizes. Okay, two things happen when shapes are similar. First of all, the angles are congruent to each other, and second, sides are proportional. Okay, meaning their sides are in proportion with each other. All right. The similarity ratio is what you get when you compare the sides. They should break down to the same fraction. Okay, so we take a side from the small shape over its matching side from the big shape, and then make sure we reduce it. Okay. Last, we have something called the golden ratio. The golden ratio is a very commonly used ratio for building such things as tables and windows and stuff like that, and it's always 1 over 1.618. Okay, the 1 represents the width, and the larger number, 1.618, represents the length. So let's try some examples. In example 1, quadrilateral ABCD is similar to quadrilateral EFGH. So A matches E, B matches F, and so on. Okay, so we're just going to try to identify what's happening here. Okay, so let me move this over so we can see it. In our first example here, what is the measure of angle E? Here's the measure of angle E right here. Now angle E matches angle A, and they're the same, so it's going to be 53 degrees. And next we have a proportion set up. We have segment AB, which is right here. Here's segment AB over EF. Here's EF. And that's equal to segment AD over what? Now what matches AD would be over here EH. So EH would be our answer. Let's try another angle problem. This one, that asks us to find the measure of angle B. Measure of angle B is going to match the measure of angle F, which is 127 degrees. Okay. And finally, we have another proportion problem. So this one's GH. Here's GH right here. GH over CD. Those match. And that's equal to FG. Here's FG over, that's going to be BC. Next thing we're going to do over here with example 2 is we're going to determine if these triangles are similar. If they are, we're going to write the similarity statement and give the similarity ratio. Okay, so first thing we're going to check, are the angles congruent? All right, do the matching angles, are they the same? So if you look at angle A has a tick mark or a congruency mark with angle F, so those match. Angle B and angle E match, and angle C and angle D match. So that's a yes. If that was a no, if one of them didn't match up, then the shapes are not similar. So now we can continue. Okay? Now let's talk about the sides. Are the sides proportional? So what we're going to do here, let me clear this off here. We're going to take a look, see if the sides are proportional. So let's start with 15. 15 over, and 15 matches. Sorry about that. 15 matches 20. So if I divide those two, I get 0.75. Okay. 12 matches 16. When you divide those two, you get 0.75 again. And finally, 18 matches 24. So 18 divided by 24 is 0.75. Notice all of these are the same. That means the sides are proportional. Now 0.75 as a fraction is 3/4. So 3/4 is our similarity ratio. Now we can write the similarity statement, which is going to be triangle ABC is similar to triangle, and I want to put this in the same order. A matches F, B matches E, and C matches D. So triangle ABC is similar to triangle FED. Okay, our last two examples here deal with figuring out some missing lengths. In this case, triangle ABC is similar to triangle XYZ, and we're going to find the measure of AC, which is labeled with an X. Now, since the two triangles are similar, we know that their sides are proportional. Okay, so I'm going to set up a proportion. Now, from this side, the smaller triangle, I have X and 12, and over here from the bigger triangle, we have 40 and 30. Okay, notice they match up. X matches up with 40, 12 matches up with 30. So all I'm going to do is simply cross multiply those, and if I do the calculations correct, X would be 16. Okay, finally, number 4 says the length and width of a rectangular tabletop are in the golden ratio. So in order to solve this, I'm going to have to set up a proportion. The golden ratio I'm going to put on the left side, so it's 1 over 1.618. Again, 1 represents the width or the shorter side, and 1.618 represents the length or the longer side. It tells me the width of this tabletop is 40, so I know that's going to go on top across from 1, and I'm looking for the length. So all I'm going to do is cross multiply here, and I should be able to get my answer. So let's calculate that out. I'm going to multiply 40 times 1.618 and then divide it by 1, and we end up getting 64.72. And that concludes our lesson on similar polygons.